G'day, my name is Brendan, and I'm going to talk about Linux performance in 2018. This is something that I do at Netflix, and so giving a state of Linux performance is very easy for me to do. But the first thing I want to discuss is that Linux changes very rapidly. We have a release every 2 to 3 months, and I've got a chart here, you can check it out online, that shows how many commits appear in each of the Linux releases. There's about 10,000 commits and about 1 million lines of code change with every Linux release. There's two problems with this. One problem is it's hard to keep up to date with what's happening with Linux. And so I'm really grateful to have this opportunity to summarize what's been happening in Linux performance here today. Another problem with Linux and the rate of change is that Linux doesn't really do much marketing. Linux is not a startup that's competing with many other companies who would have a VP of marketing and a marketing team and a marketing budget. And so what often happens is there's some really cool and interesting features go into Linux that you don't hear about. And so I get to talk about some of them now. I'm an engineer and I do this technically, but you can treat some of this as a way to get awareness that marketing normally would have served. How do we keep up to date with Linux? I subscribe to LKML. It's something I would not recommend anyone else doing unless you're doing kernel engineering. LKML is the Linux kernel mailing list. It gets around 400 emails a day. I don't read them all. If I tried to read them all, I would get nothing else done. And so what a lot of us do is we filter based on the subsystem we're interested in. So I'm always looking at performance updates. I'm looking at BPF updates and so on. Something that's much more gentle is to subscribe to Linux Weekly News. And this is especially helpful as they have technical journalists who summarize what's going on in Linux, and they will do updates about 4 times a week to show what's going on in the Linux kernel. But if there's one thing I'd like us all to do, and that is to check kernel newbies. Does anyone already check kernel newbies? So we've got about a dozen people. So they have an update every time there's a new Linux kernel release, and you can treat this as the release notes for Linux. At the top of that update, they have a summary of prominent features that's about a paragraph long. And so if there's just one thing I would like you to do, one takeaway, and that is every 2 to 3 months, check out the kernel newbies when they do the update and read that paragraph so that you have awareness of what's going into Linux. But what's happening in Linux in 2018? The first topic I'd love to talk about is Meltdown Inspector. Hands up if you've heard about Meltdown Inspector. All right, pretty much everyone. Meltdown Inspector are terrifying security vulnerabilities. And they involve speculative execution and low-level processor details. I have never seen an issue as bad as this ever in my career. And in order to fix Meltdown Inspector, there was simply no simple way. Intel couldn't just release a microcode update that fixed everything. And so what's ended up having to happen is every piece of software we touch and hardware has had to change to mitigate these vulnerabilities. If you are deployed in a cloud, the cloud hypervisor has had to change. So there's been patches. If you're on Amazon EC2, you'll know early in January performance went down a bit, then it improved a bit when they updated that patch. The Linux kernel, which I want to talk about, it has its own patches. It's the kernel page table isolation patches. Applications like MySQL, all applications need to be recompiled with the new retpoline compiler option. And then CPUs have microcode updates as well. So this changes everything. And all of these have a performance impact, all of these updates. It is terrifying. Fortunately, the engineers working on this have paid close attention to performance, and so the degradations we will suffer in 2018 won't be as bad as they could have been. To give you an idea, I ran MySQL with a Sysbench workload on Server Array, which was Linux 4.14 before the KPTI patches. I was accomplishing 31,000 requests per second. On server B, which is the same server, but just with the KPTI patches applied, that dropped by 27%. I'm running the system at CPU capacity just so that I can get an accurate measure of how the performance, the degradation of the performance. And the reason for the degradation of performance is it is the KPTI patches that go into Linux, they flush the translation look-aside buffer. Each time there are various events, context switches and interrupts and I/O. What happens, the TLB, and you might remember this if you did computer science many years ago, the MMU is what's used for virtual to physical address translation. Each time you do loads and stores, the MMU is translating so that your virtual memory address space, you are actually accessing main memory, physical main memory. These translations are slow. Loads and stores happen all the time in our code whenever you're accessing data. And so to speed this up, there is a side cache on the MMU called the TLB. And that's great, except the TLB has a fixed size. If things don't fit in the TLB, the hardware will then have to go to the reference, which is in main memory, and do page table walks. And that's the big problem with the KPTI patches, is they flush the TLB, so we have to do page table walks much more often. I haven't seen TLB issues for a long time. When I started doing performance about 15 years ago, I did see TLB issues, but now I've had to go and create new performance tools, and so I open sourced this TLB stat so that I can measure the CPU cycles spent doing TLB miswalks, and I could see that data TLB and instruction TLB are both higher, thanks to the KPTI patches. And so that's decreasing the instructions per cycle, which is it's like a miles per gallon. This is the #1 metric we use to understand low-level CPU performance. Fortunately, it shouldn't be that bad. And so here's some benchmarks that show I'm varying the syscall rate to show the performance loss for the KPTI patches. And it can be as bad as 600% slower if you're doing 10 million syscalls a second. If you're doing a much more gentle rate, the performance loss goes down, and there are ways to improve it. And so PCID is a kernel feature that was fully fixed in Linux 4.14. That improves performance. And there's also transparent huge pages, because the TLB normally is in 4 kilobyte page size. By using huge pages, it gives the TLB greater reach, and it can repopulate more quickly. And so I was able to bring down the performance loss you should experience. Where you are on this graph depends on your syscall rate, your I/O rate, your context switch rate, and that will tell you whether you're looking at hopefully it's only a 2% performance loss and not a 20% performance loss like my sysbench example. So that's Meltdown Inspector. A lot of work has gone into Linux to make sure that the performance impact is minimal. Enhanced BPF is another hotness of Linux for the last couple of years. And when the patches were first added to Linux, the lead developer, Alexei Storytoyov, said, this allows you to do crazy things. This is normally the words you don't tell Linus when you want him to accept patches into the kernel. But fortunately, the patches were accepted. Enhanced BPF puts a virtual machine in the kernel that we can program from user space. And so it's being used for all sorts of things, doing DDoS mitigation, intrusion detection, container security, observability. I'm particularly interested in the observability angle, and I've been creating tools. And so this is the eBPF BCC tools that are open sourced. And I've drawn a diagram of the kernel, just a generic diagram, and I've shown where the tools fit in, what each of them do. Now, there's tools for looking at file system performance. There's tools for looking at the scheduler performance and so on. What BPF and the enhancements to BPF lets us do is the Linux kernel already had a lot of instrumentation. So it had kprobes for kernel dynamic tracing, uprobes for user-level dynamic tracing. It had ftrace, it had perf events. eBPF gives us programmatic functionality so that we can create custom latency histograms in the kernel. We can associate events together. I can create a custom timestamp from one event and then retrieve it another so that I can look at latency at different points. One of my favorite types of tools is inspired by, in databases, when you have wait states and you want to break down a query into the different states where it's waiting. And so I like to do that with kernel events as well. Where am I waiting during a file system operation, or where am I waiting when I'm waiting on the scheduler to schedule me back on CPU? And BPF lets us create all these new tools for new insights into how the kernel runs. And so this is all open source. You do need to be on at least Linux 4.4 to make use of them. And the newer the kernel you're on, the more of the tools will work, as eBPF has been added piecemeal. To give an example of an BPF tool, this is bio latency, and it's showing block IO disk latency, and it's summarizing this histogram in kernel, so it's very efficient. The only thing that's passed from kernel to user space is the count column, so it's just an array of numbers. Normally, prior to eBPF, we had to dump all block IO events to user space and then post-process, so it was prohibitive in terms of 24/7 monitoring, but now we can do these custom histograms in the kernel, export them out, monitor them 24/7. Not just for disk latency, but for anything, TCP latency, scheduler latency, and so on. Another example tool to show a different type of capability out of BPF is my off-CPU time tool. This is rather interesting as it's showing the kernel stacks when you block and go off CPU versus the time it takes to go off CPU. Has anyone used CPU flame graphs? CPU flame graphs. All right, so we have a lot of people. CPU flame graphs show why an application is consuming CPU. Off CPU flame graphs are their complement. This shows why you block, and then the stack trace is responsible for blocking. This is MySQL, and I'm running it with a workload, and I can then investigate the off-CPU time, the blocking time, whether it's in locks, whether it's in disk I/O, whether it's in scheduler latency. It's a really great catch-all for everything that's not exposed through a normal CPU profile. And so I really like using this to complete my analysis of what an application is doing. But there's other uses of BPF as well. So this is XDP, and this is a feature that was added into Linux 4.8, and it's been getting enhanced and improved. XDP is using BPF to improve in-kernel networking and to speed things up. This graph is from Netronome, and it shows how normally with IP tables, BPF can make performance 3 times better, doing 3 times the packet rate. And with hardware offload on cards, which is now starting to appear on networking cards, we can take that even further. And this is one of the reasons why IP tables is now giving way to BPF-based solutions in Linux. There's going to be a lot more of this. I work at Netflix, and quite often people say, I would like you to try out our monitoring solution. I'd like you to try out our software solution from startups. Often these involve running an agent on our systems as root. Now, that makes me a bit nervous, and it makes our security team a bit nervous about trusting a startup with running an agent as root, because a root daemon can do basically anything. BPF is really interesting because it allows things to run in a secure virtual machine, a sandbox, where it can't interfere negatively with the kernel, and it can't do anything naughty that it shouldn't do. All the BPF programs go through a verifier first. So we will see over time more and more things like XDP, where some great kernel capability, instead of being made available through kernel patches or through a daemon that you have to run, it's now made available through a BPF program. Someone has already predicted that in the future, there will be no more loadable modules from third-party vendors. These will all become BPF programs. And I can see that's the dream, but I can see where that's heading as a Netflix employee, because if third parties are coming up and saying, run my BPF program, I know it's running in a sandbox context, and so I can trust that much better. Other exciting things that are happening in Linux, BBR is the new TCP congestion algorithm that was contributed by Google that appeared in Linux 4.9. And it's been designed to really excel with packet loss environments, which is what we see in the real world. My colleague, Amma Ather, on the performance and operating systems team at Netflix, he's been testing this on 0% packet loss networks. BBR does not help, so its performance is the same as Cubic. But once you start to add in some packet loss, which you'll see for external networks, BBR really starts to excel. These graphs from Amma show a 1% packet loss where BBR is able to maintain 3 times better throughput than Cubic. And so there's some other references in my slides. BBR is exciting. We're looking to deploy and use that more. Another interesting feature I wanted to mention is Kyber. Kyber was added in Linux 4.12 along with another I/O scheduler. And this is improving the read and write latency to storage devices. How it works is it has target read and write latencies that you can tune. The target read latency, I think by default, is 2 milliseconds, and the write latency is 10 milliseconds. What normally happens, or to put it this way, when someone tells me I have a storage I/O problem, I have really bad storage I/O latency, there's usually 2 culprits. One, the disk is dying, and you're seeing really crazy I/O latency. Or 2, you've got queuing. And so the kernel has done a write flush and has sent out 100 I/O or 300 I/O to the dispatch queue. And then you've done a high priority read that's blocking the application, and that read is queued behind all of the writes. So Kyber, it keeps the dispatch queues very short. So we'll never send 100 write I/O to the dispatch queue, or we might. Kyber looks at the I/O completion times, so it understands if I feed that many I/O into the write queue, and then a read comes along, what's its latency going to be, and will I be able to satisfy a target? And so it constantly adjusts the length of the dispatch queue based on feedback of how the I/O subsystem is working. So and it actually works. We've tested it, and we've found that our 99th percentile latencies can be reduced as much as 300-fold thanks to Kyber. And that was contributed by Facebook. But there's a lot more has been happening in performance in Linux. From 4.4 to 4.16, there's been TCP listener has become lockless to improve it. We've had the copy file range syscall for improving performance there. And there's been many ePOL related improvements. There's the kernel connection multiplexer, which should improve network performance, and so on and so on and so on. There's the BFQ I/O scheduler was added as well. There's also many minor improvements. So one of the biggest things that's been developed is the Linux perf tool, Linux perf. And so it's been getting capabilities so it can look at scheduler statistics, the sched time hist. It's been getting eBPF capabilities and so on. And so it's much more powerful now. CPU scheduling is always getting improved. Futexes, NUMA, huge pages, and so on. And so the newer Linux kernel you can get on, the better, because there's always these constant improvements that are happening. If you're wondering how I can keep up to date with all of this, then that's kind of the point. It's how do we stay relevant and up to date, and that's to browse the major features on kernel newbies. It is a really good source for understanding the new things that are happening. And so you can do that. It's, like I said, this is a very low commitment for us all to do. I know we're all busy, and Linux is just one small part of everything that you do. And so once every 2 to 3 months, there'll be a new release notes, and you can just look at the major features and see what's interesting. but also to run latest, because a lot of work does go into it, and that is, it's something a lot of engineers, we're very proud of what we get into Linux, but it can take a while for it to get deployed into production. So please run latest whenever you can. I have some Linux performance resources as a final slide, and that's my talk. Thank you very much.